Assalamualaikum. My name is Muhammad Shahmi bin Jaim and my matrix number is DE240163. Today I'm going to present about our system design based on our project. As you guys can see on our system design slide, we carefully selected our prototype materials based on magnetostatic principle. We use a steady-state DC battery that connected to a manual control switch. The core of our design relies on a copper coil wound around a soft iron core. We specifically choose soft iron due to its high magnetic permeability, which works alongside Ampere's law to focus our magnetic flux density. Finally, the entire chassis is constructed out of wood to provide rigid structural support without introducing any non-magnetic interference. The core engineering choices behind our design are directly governed by the magnetostatic formula as shown in the slide. We optimize three critical parameters in this formula to make our crane highly efficient. First, the number of turns, which is representing by N, and also current, which is representing by I. Because magnetic flux density is directly proportional to N and I, we maximize the number of copper wire loops within the tight physical constraints of our crane arm to ensure a strong lifting capability. Second, the core material, which is represented by mu. We specifically selected a soft iron core because its high magnetic permeability that acts as an excellent conductor for magnetic flux lines, where it concentrating them to maximize pulling force. Third, the path length, which represented by L. We kept the coil wound tightly along a short length to prevent the magnetic field from becoming weak. Finally, you'll notice our structural crane frame is built entirely out of wood. This is because wood is a non-magnetic material which guarantees zero structural interference with our magnetic flux line.
Assalamualaikum warahmatullahi wabarakatuh. My name is Farid Izham Jana and my matric number is DE240148. So next, I will explain the operation of our electromagnetic crane model. Our prototype works by converting electrical energy into magnetic energy. The entire operation begins when the switch is turned on. First, the battery supplies the direct current to the copper wire coil that is wrapped around the soft iron nail. As the electric current flows through the coil, a magnetic field is generated around the iron core, according to the principle electromagnetism. The soft iron nail becomes a temporary electromagnet. Once the electromagnet activates, it produces enough the magnetic force to attract and lift nearby ferromagnetic objects such as screw, washer, or paper clips. The object remains attached to the electromagnet as long as the electric current continues to flow through the coil. When we turn the switch off, the circuit is open and the flow of electric current stops immediately. Without the electric current, the magnetic field disappears, causing the soft iron nail to lose its magnetic properties. As a result, the metal object is no longer attracted and is released from the electromagnets. This simple process demonstrates how an electromagnetic crane easily lift and release metal objects simply by controlling the electric current. This same operating principle is used in industrial electromagnetic crane found in recycle plants, steel factories, and ports. In summary, the operation of our prototype follows four main stages, which is power is supplied, the magnetic field is generated, the metal object is lifted, and finally the object is released when the power is switched off. I think that's all from me. Thank you.
Assalamualaikum. My name is Muhammad Afar bin Zainuddin. My matrix number is DE240135. So I will be explaining about the principle behind our project. So our project is based on magnetostatic, which the study of magnetic field produced by steady or constant electric current. In our project, but the battery supply the direct current, which is DC. So magnetic field produced is stable while the switch is turned on. And it is Ampere's law. According to Ampere's law, whenever electric current flows through a conductor, it creates magnetic field around the conductor. Uh, each turn of the wire produces its own magnetic field, and this magnetic field combine to create much stronger magnetic field. So the the wire and the turns. Uh, and to lift the metal object when the switch is turned on, the crane itself will be electromagnet, and it will attract material such as iron and steel. And when the switch is turned off, the electric current stop, and magnetic field will be disappear.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Afiq Mirasli, metric number DE230103. So I will present the mathematical model of our prototype using Ampere's law for a solenoid. So B equal to mu n times I over L. So this equation shows that our crane magnetic lifting strength B is controlled by three main variables. First, core permeability mu. We apply this by using an iron nail, concentrate the magnetic field lines, making the magnet much stronger than using a plain hollow coil. Second, turn density N over L. This represents our copper wire loops. Increasing the number of turns directly multiplies the magnetic field strength. Lastly, the current. So this is the electricity from our battery. Flipping the switch on provide the current to lift the metal. Flipping the switch off drops the current to zero. I equal to 0, causing the magnetic field to instantly collapse, so the payload drops clearly. In conclusion, this formula proves how electrical energy is calculated and converted into mechanical lifting force in our design. That's all from me. Thank you.